For today, we're going to start analyzing the normal model, looking at data how it represents the 68, 97, 99.5 or 95, 99.7 model. So, the WIS for children is approximately a normal distribution with a mean at 100 and a standard deviation of 15. Draw and clearly label this model. So first off, let's look at the mean of 100. Where do you think the mean fits with our normal model? Where would I put it?
In the center.
In the center. Very good. So let me write 100. Right here, dead in the center. If you have a perfect normal model, that's where it'll be. Now notice, life isn't perfect, but we are going to make assumptions off of this. And it has a standard deviation of 15. So if I'm moving one standard deviation from 100, what does that give me? What value? 115. And if I'm moving two standard deviations from my mean, where do I land? 130. And if I move 3, where do I spit? 145. Yep. So that's 1 standard deviation, 2, and 3. Now if I go this direction, what value goes here for the mean? 85. Very good. So you're subtracting the 15 from 100. This is a minus 1 standard deviation. What would be a negative 2 standard deviations? 60? 70. Okay, thank you. And then 3 standard deviations, or should I say a negative 3 standard deviations, would be what? 55. That sounds good. So this is how you're going to draw your model. The mean is in the middle, and your deviations are plus or minus that from here. Between what two values would I find my 68 percentile? What's that? 85 and what? 115. Yep. This is going to be my 68%. Between what values will I find my 95%? 95% of my data falls within 70 and 130. So this represents the 95. And where would I find my 99.7? Between 55 and 145, 99.7%. Again, that's called your 68, 95, 99.7 rule, or empirical rule as we saw yesterday. Just like so. Okay, let's see if we can solve this using our Z-score. Adult female Dalmatians weigh an average of 50 pounds with a standard deviation of 3.3 pounds. Adult female boxers weigh an average of 57.5 pounds with a standard deviation of 1.7 pounds. One statistics teacher owns an underweight Dalmatian and an underweight boxer. The Dalmatian weighs 45 pounds and the boxer weighs 52 pounds. Which of these dogs is more underweight? And explain. So like I said yesterday, the Z-score, what it does is it measures how far off from the mean you are given your point range. So this stats teacher will start with the Dalmatian, weighs 45 pounds. That's going to be my observed value, 45 pounds. So for the X, I'm going to put a 45. And I'm going to subtract that to this, which represents the mean. What is the mean of my Dalmatians? 50 pounds. So 45 minus 50. All over, and here is the standard deviation. So it's going to be divided by the standard deviation, which is what? 3.3. So take 45, subtract 50, divided by 3.3. And you get a negative 1.5, we'll say, roll around the 2. That means this negative, it is below the mean by 1.52 based on that standard deviation. So that's how far off this dog is from the average. Now let's look at Boxer. The stats Boxer weighs 52 pounds. Again, that is my observed value. Oops, 52. So 52. I'm subtracting that to what?
57.5.
Very good. The mean of the Boxers, 57.5, and dividing it by what value?
1.7.
Yes, the standard deviation is 1.7. And so 52 divided by 1.75, or subtract 1.75 divided by 1.2 is negative 3.2. So which dog is more underweight?
The box.
Yes, well, I should have labeled these, I guess. Boxer, Dalmatian. So yes, the Boxer is a lot more underweight than the Dalmatian, based on its mean. If you had looked at this, you would see that, well, the Dalmatian weighs less, right? Well, not based on its average of its breed. That's what Z-score is showing us. Now, say we were to adjust these values. For example, what if the average on the test was a 65? And I'm like, oh, that's horrible. So I'm going to give y'all a curve by adding 10 points, making the average 75. How does that adjust everything, like Z-scores and standard deviations? What happens is the measure of center and position are affected by addition and multiplication. So I think it looks better if I can do this. Let me bring this up again. Here we go. Here we go. Can I make this bigger? Where's my picture? There we go. So, if I'm adding a value, notice it the Q3, the max, and the min move with it. Notice my median also moves with it. But does moving up, adding or subtracting values, affect the IQR, the range?
No.
No. As you see, does this get bigger or smaller as I'm moving up? No. So the IQR is not affected. What about the standard deviation? Does that get affected? No, it doesn't. So notice how the distance between my red and blue is the same. So those are the two values that when you're adding or subtracting do not get affected. Now what if I were to multiply, which is doing this? Oops, can I do that here? There we go. Multiplying. Now does my IQR and standard deviation change? Yes. So that changes with multiplication. As you see also, other things change as well with multiplication. So everything changes with multiplication. Adding and subtracting, which is doing this, well, the IQR and standard deviation are not affected. So let me go back. Let me go here. Suppose the class took a 40-point quiz. Results show a mean of 30, median 32, IQR 8, standard deviation 6, min 12, and Q1 27. Suppose you got a 35. What happens to each student if I decide the weight of the quiz is now 50 points? So I'm going to add 10 points to every score. Your score is now a 45. So let's see. The mean. I'm going to call them these original values y. Does the mean change? Yes. What does the mean change to?
40.
So I'm adding 10, so it changes the mean up to a 10. Again, visually think of that thing going up and down. The median, does that change? What does it change to? 42. IQR, does that change?
Wait, no.
No, it doesn't, right? Remember, because I'm adding 50 points, that difference is still staying the same, still staying constant. So that's an 8, stays the same. What about my standard deviation?
No.
No, stays the same, that's a 6. Minimum, does that change?
Yes.
My minimum's now a 22. My Q1 is now a what?
37.
37. And then your score is a 45. that make sense?
Yes.
Okay. What if I were to decide that the weight is now 80 points? So I'm going to double each score. What happens to my mean? It becomes a 60. Yeah, so take this number and double it. Multiply by 2. 60. My median, what happens to that score? It becomes a 64. IQR, does it change?
Yes.
It also doubles. It becomes 16. Standard deviation
Becomes 12.
becomes a 12. And then minimum, 24. Q1,
20. No.
27 times 2, 54, thank you. And 35, your score is now a
70.
It's now 70. Hey, looking better. All right, what if we were to do two things? I decide the weight of the quiz is now 100 points. So I'm going to double each score and add 20 points. Your score is now 90. So I'm going to take my y, double it, and then add 20. So what becomes the mean?
Mean becomes 80.
Yes, now the average score is an 80. The median,
84.
84. Oh, I'm trying to write there, 84. The IQR,
16. Because it's double, right?
it's 16, it's double. Does it get the 20 added? No, very good. That is just a 16. The standard deviation,
It's just 12.
it's 12. It's also not affected by the adding 20. The minimum, 44. So 12 times 2 plus 20. Q1, 27, 74. And then your score is a very nice 90. Okay, so that just demonstrates how things adjust, like I showed here. Last but not least, consider 3 athletes' performances shown below in a 3-event competition. Note that each placed first, second, and third in an event. Who gets the gold medal? So here's competitor A's scores, B's, and C's. It gives me the mean of each of these events and their standard deviation. So with this data, what do you think we should look for? What value has a point, mean, and standard deviation in its calculation? What's it called? We just talked about it with the Dalmatians. Z-score. So yes, let's calculate the Z-score out of all of these and then add them up. Next hint, here they go, Z-score. And then what am I looking for to decide who's the champion? What about their Z-score? Once I have their Z-score, how do I decide who's the champion? The highest, right? Whoever has the highest Z-score. That means they had the best out of all of the best from the mean out of all of these events combined. So one by one, I'm gonna do this one and then I'm gonna do the rest just straight off the calculator. So competitor A had a 10.1 dash. I'm going to subtract that to the mean of 10 and divide that by the standard deviation of 0.2. So 10.1 minus 10 divided by 0.2 is a 0.5 Z-score. So let me make note of that here. Shot put. So he scored a 61. The mean, so subtract that from 60, divided by the standard deviation. 66 divided by 60 divided by 3 gives me a Z-score of 2. And then the long jump. So his score was a 26 out of 26 with a standard deviation of 0.5, which is 0. He was the average. So if I add those together, I have a Z-score of 2.5. Now let me give you a minute, calculate the Z-score of the other two, and then pick a winner. So what was my Z-score here for competitor B's 100-meter dash?
-0.5.
-0.5. What about his shot put? 2. What about long jump?
4 and two.
That was also a 2. So it gives me a grand total of 3.5.
Yeah.
Okay. So we know competitor B did a lot better than A. Let's see how competitor C did. So what was my z-score here?
I just put it all in one equation.
2.3
1.5.
1.5. Hey, so far so good. He's already halfway there. His shot put?
1.
A 1. All right. He's now at 2.5. And then his long jump. So now that's 3 inches. So we got to do 3 divided by 12. So that should be a 27.25 minus 26 divided by 0.5. Or oops. 1.25 divided by 0.5. Did you get 2.5? 1.5 plus 1 plus 2.5. I got a 5.
Yeah.
Something seems off there. Oh, is this the negative? Do you mean this to be a negative? Okay, so this is negative 1.5. So it takes, so this is going to be a 2. So your numbers should look like this, which means B won, right? Competitor B wins the gold medal. Who gets the silver?
C.
C, and then the bronze goes to A. Now let's look at this. Who turned in the most impressive single performance out of all the events?
The C's shot. His long jump. His long jump.
C's long jump, right? It had the highest z-score. Yes, C's long jump. That was the best out of the average of the competition, or the greatest value. Okay,